Ben seni bir şey yapayım önce, sonra paylaş.
Tamam, peki.
Bir tanıtayım ondan sonra. Okay, today we have the fourth of lunch and seminar. And I have the honor to host Aykut Lenger from Ege University, Department of Economics. First of all, let me introduce him a little bit. He was born in Izmir in 1969, and in 1994, he got his undergraduate degree from Ankara University. And he got his master's degree in 1998. And he started working in Ege University in 1995. And he started his PhD studies Middle East Technical University, Department of Economics in 1998. And then he got the scholarship of Türkiye Bilimler Akademisi in 2003, and he went to Italy, to Pisa, Scuola Superiore Sant'Anne, Laboratoria di Economy Management. This was the department. And he got his PhD degree in 2004, and he started working as assistant professor in Ege University in 2005, and as associated professor in 2008 in the same university. And he went to United States in 2011, University of California, Los Angeles, as a visiting research professor. And in 2015, he became a professor in Ege University, and he's still working in the university. And his areas of interest are development in technology, innovation, dynamics of industry, economic growth, efficiency, and regional economics. And he attended lots of meetings and congress, and also he has several publications in different journals. And today he will present his paper titled as Are Resource-Rich Economies Too Rich to Save? So I could, the floor is yours. We are ready to listen to you.
Thank you very much for this intro. And I would like to say that's also a great honor for me to be here, to be invited by you, and to meet with the scholars of your department. Let me share the, yes. I'm not sure if I do that full screen, can you see it in full screen? But I think this is okay for the moment. The title, as you mentioned, that it's Are Resource-Rich Economies Too Rich to Save? This is in fact a joint paper with Felix Ramandray of Université Catholique de Madagascar and by me. I'm going to present in this, let me first start with the plan of the presentation. I'm going to give a brief description of the literature and the, where it starts or where it originated in the literature here in the study. And I'm going to explain the motivation, therefore, and the objective of the paper. And I'm going to put the resource rents, which we are interested in this paper, into the growth model, which in fact is, growth model with consumer optimization, like Ramsey Kaas-Koopmans type of growth bubble. Then I'm going to explain the empirical strategy. And then finally, I'm going to present the results and discussion. Sorry. The export of natural resources are expected to bring huge rents to the economy because it increases your, obviously, both GDP and income level. However, we see that this is not always the case. And when you increase your income level originating from your natural resources, of course, let me explain first, when we mention about the natural resources, this can be oil, natural gas, mining, forest, and all kind of natural resources we are talking about. And the income generated from this kind of natural resources, the economy is expected to increase its investment level, and therefore, of course, you expect a boost in your economic growth. And this brings you, especially for underdeveloped, or let me say developing countries, not like the United States, of course, or Norway. They are also oil-rich countries. But if you are lacking the necessary capital infrastructure in your economy, this income generation out of natural resources can allow you to import the necessary capital goods to build your infrastructure. Also, governments can invest in education projects, enroll more students to the general school system or also universities, and in this way you can also increase your human capital accumulation, which is also directly correlated with economic growth, as it has been manifested in the new growth theory in the last 30 years. However, even though we have such benefits and advantages out of natural resources, we observe that many resource-rich economies exhibit poor economic performance. I mean, in terms of their economic growth rates, their unemployment levels, and this kind of stuff. So, what could be the reason? Are economies with abundant natural resources endowed with this kind of natural resources cursed? So there is a hypothesis in this specific issue, that explains this dilemma, which is called the resource curse hypothesis. Resource curse hypothesis. Even though you are endowed abundant natural resources, you have a sluggish growth rather than an economy without natural resources. So the literature discusses the reasons can be manifold. For example, it can be Dutch disease. Because when income generated, when you export your natural resources, of course, your oil, natural gas, or the other kind of resources, your currency, the local currency, will be revalued because of influx of foreign exchange into your economy. Therefore, you will lose competitiveness in international markets, and which brings you a sort of a shift away from other productions and or manufacturing, and all resources would be attracted to resource sector. I mean, natural resource sector. And the crowding out of manufacturing and other kind of production activities by this resource sector is also mentioned. And when the resource sector activity increases in an economy, wages also increases, and which also brings a sort of loss of competitiveness. And when the resource sector accelerates, you also put more effort and resources into this economy. Also, your human capital also, will leak into resource sector. And in manufacturing, there is a huge possibility of doing some innovation and increase your efficiency by learning by doing, because as you work on some complex productive activities, like, in electronics or even in textile, let me say, even in textile, which is a very low-tech industry, you can acquire some kind of efficiency gains, and you can induce some innovation by, learning by doing, as you take away resources from other production activities like manufacturing. So your human capital flows into resource sector, therefore you cannot benefit these kind of advantages. The literature discusses, I'm going to give those literature in a moment, but let me briefly explain them. Mainly discusses the lack of institutional and political quality, especially in African countries, in some African countries. And it brings you some kind of inefficiencies, because, if you are not conducting your policies and you're not conducting the tasks you have to do correctly, then it arises some kind of inefficiencies. Also, the opportunity of reaching huge windfall gains in an economy will increase rent-seeking and lobbying activities, which is discussed in economic theory, which is, directly unproductive and without any fruit for the economy. You put a lot of effort in rent-seeking and lobbying just to solve a problem of distribution, okay? And this distribution is not always a fair one. And therefore, this also reduces the economic growth in any kind of economy if it is end up with natural resources. And also, lack of governance and corruption is also discussed, because especially in less developed countries, like in Africa, corruption is very, very, central problem in the governance, and this is also obviously limits the economic growth in such kind of economies. So I'm going to focus on because of all of these reasons, the inability or rigidity of pouring resource rents into capital investments, which limits economic growth, because the link between the resource rents and investment, therefore, is demolished, and we cannot obtain higher economic growth in that sense. The literature, as I said, there is a huge body of literature discussing Dutch disease, human capital leakage, corruption, lack of political quality, and institutional quality. Also, institutions are very important, which I have mentioned here. Not only political quality, but the institutions are not capable enough to produce the outcomes that are, if the institutions are not very conducive for economic growth, then of course there will be again a limiting result of economic growth. And that's why we can explain the resource curse in that sense. You have a huge amount of windfall gain from resource rents, from natural resources, but your economic growth is not as it is expected. It's not at the level of that you expect. All right, so as I mentioned, I'm going to specifically focus on the link between the capital investments and natural resources. The literature for the last 50 years almost, starting from 1974, examined the relationship between the natural resources, capital investment, consumption, how is it, affected by resource and consumption, and related another issue is the sustainability of this kind of economies. If they are increasing their consumption level to a higher level and if they reduce their investment level to a very low shares, then the sustainability of this economy, not only in that sense, but also those resources are mainly non-renewable resources like oil or natural gas, you cannot, I mean, it's not like a solar energy, okay? It's not like a solar energy or wind energy. You cannot renew them. That's why there will be an end sooner or later to the stock of these natural resources. So they discuss these kind of issues like Solow-Stiglitz, Dasgupta, and Hill. Hertwig rule is very important here in 1977 and 78. And until this year, there are, studies investigating this relationship, capital investments and, consumption sustainability and the natural resources about this issue. Okay, what are we going to do in this paper? Well, our objective is to investigate the resource curse hypothesis by specifically focusing on the relationship between the resource rents and investments. I mean, the gross investments in this kind of economies, if they are end up with natural resources. Why do we do this study? Because we want to formalize the relationship between the rents and investments in an economic growth model, which has not been, in fact, formally done. There are some other models, as I have mentioned in the literature part, for almost a half century, but not in that type of, the Ramsey-Cass-Koopmans types of economic growth model. We are going to try to link the resource rents with the economic growth model, and this is a sort of contribution to the literature. And we also take another, an approach, empirical approach that allows us to represent the investments as a function of resource rents. As we link the resource rents in an economic growth model to the investment level, we will be able to function or represent the investment level as a function of resource rents. This our empirical strategy will allows us to do that. Generally, the previous studies directly analyze the effect of resource rents on economic growth by taking the regressing many different type of course econometric analysis, and they are focusing on the coefficient of the resource rents on economic growth. However, due to this relationship I have just explained, in an economic growth model, there will be a resource rents, there will be a relationship, resource rents and investment. We can say that there can be an interaction in the model. That's why we have to take into account this. All right, so our hypothesis is that the investments in the resource-rich countries are suboptimal, all because of all of these reasons we have discussed. And also, let me say that this is also, it can be also be discussed within the sustainability issue. When an economy, are given the opportunity of having windfall gains from export, of course, export of natural resources, your current consumption is overvalued versus future consumption in this kind of economies, because in this kind of economies, economic or political agents, or in fact all agents, they don't feel any threat against the uncertainty of future. Okay, so the future will bring you a lot of income, so you feel yourself very relaxed, and this economic environment raises the self-confidence on this economy. So they don't feel very much obliged to save and invest. Okay, so their investment level that's why can become suboptimal. It can be less than the optimal level. In addition to the reasons we have seen in the literature, all of the reasons, the institutional quality, political quality, this kind of stuff. So, but why are investments important? Because there is a sustainability issue. The oil and natural resource reserves, natural gas reserves, I'm sorry, this should be natural gas reserves. will be sufficient to meet the consumption in the next 47 and 53 years in future. So oil will be sufficient for 47 years, and the natural gas will be sufficient only 53 years. Okay, so obviously these kind of economies should be more careful about their designing their future if they don't invest enough, if they don't develop more diversified manufacturing activity, for example, or other kind of services activity that will bring or generate some income, of course. And there is another threat in the case of any technological paradigm shift. You know, the recent trend is the electricity powered automobiles. Okay, this will reduce the demand for oil, and of course, if the demand reduces, the price will be very low, and the income generated by this economic resource will be very low within perhaps in 10 years. So this is also another threat. So they should be more careful about their investments level, the resource-rich economies. Okay, so the literature I have just discussed, in fact, gave you are generally very pessimistic about the link between the resource rents and economic growth. However, there are some also optimistic ones that they find these kind of studies, for example, are in Braunfels, Jalili and others, Mehlum and others, Apergiz and Payne. They find positive relationship between economic growth and resource intensity. And that's why, obviously, this is a matter of economic approach or econometric approach that for your empirical strategy. Some of them are cross-section analysis, which is, of course, with its econometric problems, and some of them are, you know, panel data, but still the estimation methodology and this kind of issues should be more taken into account more carefully, let me say. All right, let me then produce the growth model, how we linked or plugged the resource trends into the neoclassical economic growth model here. We represent the production or GDP generation in this economy with three inputs: the capital stock, physical capital stock, labor force, and resources. Okay, we have three inputs, and capital stock is generated as usual way as it is hypothesized in Solow model. As you add more investments into capital stock, it increases and it also depreciates at the rate of a certain rate. Labor force grows at an exponential rate, which is n. It grows at the rate of n. It has an exponential function. And resources are non-renewable resources, and it's, you know, reduces at each time you deplete them. Okay, there's a resource depletion as indicated by equation 3. All right, so these are the explanations about the inputs. So we can turn the production function into per capita terms, of course, by ignoring the time trends here. We know that they're all a function of time, as we are working on economic growth right now. And the savings here in the capital is not accumulating according an equation in which the savings are defined as a constant function, but we just try the saving rate out of an household's maximization problem. The instantaneous consumption function can be represented by this function. This row here is positive, and it discounts the future utilities to the present level, and this is the famous consumption function used in this study. And let me say that the general structure that this model in neoclassical growth model is in fact inspired by the Barrow and Salahi-Martin in this presentation. Equation 6 here represents the intertemporal budget constraint. The discounted value, the present value of all assets of households, and the already wealth, the summation of them, must be equal to the current value of consumption. This expresses, and of course, assets are consisting of not only the physical capital, but we also assume that you can obtain some rate of return out of resources, natural resources, right? We can also envisage in this way. That's why instead of this taking the rate of return just coming from physical capital stock, we can assume that this rate of return is in fact is an arithmetic average of both physical capital stock, also natural resource sense. Okay, so the tau here determines the weight. It can be weighted average of assets. So the markets, in the assets markets, we can express this intertemporal budget constraint in terms of per capita levels. So we are just subtracting the growth rate of population from each of discounting variable here, R bar here, as you can see. And our per capita assets is equal to, again, when you divide this equation by L, we obtain this level, okay? This equation. So tau is in between 0 and 1. When we look at the consumer optimization problem to drive out the saving rate, we see that this the objective function is this, the maximize the utility function. Therefore, in fact, this is a Hamiltonian function. I mean, dynamic optimization problem, which it takes the future generations also, or an infinite horizon, as you can see. We write the Hamiltonian function in a dynamic optimization problem accordingly. I mean, this is the objective function plus the intertemporal budget constraint in per capita terms. So these are, you know, the assets multiplied by its rate, and I'm sorry, this is the budget constraint in terms of, you know, wage and, you know, your consumption. Okay, we express it in this way, and the solution of this problem relies on some specific first order conditions. The first one is the taking the derivative of this Hamiltonian function with respect to control variable. We have the control variable consumption here, and the asset is the state variable. So when we take the derivative with respect to control variable and equalize it to 0, we obtain lambda as the marginal utility discounted today, marginal utility per capita terms again. And the second first order condition in this problem is that the lambda dot, which indicates the time derivative of it, I mean how it changes over time, must be equal to the negative of the derivative of the Hamiltonian function with respect to assets per capita, and it must be equal to 0. And we obtain from this maximization problem, or first order condition, I'm sorry, this differential equation, lambda dot must be equal to minus r bar minus n multiplied by lambda. As you can see, this is obviously a differential, first order linear differential equation, and summation of this will determine the consumption level and therefore our saving rate, which turns into, obviously, the Keynesian assumption still holds. All investments are directly transferred into, I'm sorry, all savings directly transferred into investments. And this transversality condition defines that at the end of the time horizon, there will be no assets. Okay, so this terminal condition should also hold for the solution of this problem to have a maximization. Otherwise, it will be exploding. Okay, it will be exponential, and it will tend to infinity. Your assets, for example, your wealth will tend to infinity, which is not the case. In order to have maximizing point, we need to impose this transversality condition. Okay, by differentiating equation 11, which is this here, the first one, we obtain this. So we obtain another differential equation. And if we substitute equation 11 for lambda in this in equation 12, and using equation 13 here, if I put it here, we have this differential equation. We can obtain this. I mean, after these kind of rearrangements and manipulations, we obtain R bar is equal to the subjective discount rate by each consumer, of course, or the representative consumer, will be equal to the second derivative of the utility function multiplied by C, divided by the first derivative multiplied by the consumption growth. This should be subtracted from the subjective discount rate to obtain the rate of returns in this economy. And we can define this sigma as the measure of the relative risk aversion here. In fact, I'm explaining the whole growth theory here, and I don't have to spend that much time. And in the end, I obtain the optimal consumption path for this economy. C dot over C, the growth rate of consumption must be 1 over C minus R bar, multiplied by R bar minus rho. In the end, again, this is a differential equation, and the solution can be expressed in this by this equation 17. Consumption must be equal to this expression. It should grow exponentially at the rate of 1 over sigma multiplied by R bar minus rho. So when we look at the firm's behavior in this economy, we have also a maximization problem. The objective function, again, a profit function for a representative firm, or we can assume a single firm in whole economy representing the productive activity. The prices are normalized to 1, and the production function is again the same. We have represented at the outset. The profit, of course, will be equal to the payments to these inputs. RK and RR are the rate of returns for capital and natural resources, and they are flowing to these factors of production. And W is the wages, which is the payments for labor force. And we after the first order conditions, we can obtain these equalities, that the marginal productivities are equal to the rates of these inputs. So the differential equation, that governs the saving behavior in this economy, in the end, we obtain this. This is the famous, in fact, Solow equation with the savings rate here endogenized. Okay, this is the Ramsey model, in fact. So what we did is just simply plugging the resource rents into this picture, into this general framework. And after some manipulation again, I mean, if we take, I'm sorry, let me say that this 17, equation 17 here, consumption, and the 22 here, if we put that equation here, we can say that investment in capital stock is negatively related to the rate of return on natural resources. This is the main, one of the most important conclusion out of all this derivation, because we have rate of return here, which is of weighted average, of course, both capital stock and the natural resource. And that it means that there is an interaction between the investments and rate of returns. And also that should be taken into account in an empirical study. Okay, so if we take the time derivative of the logarithm of equation 4 in the outset, I mean in the per capita production function, we obtain this result. The Fk multiplied by K over Y is the capital share in production. Fr, R multiplied by Y is the natural resource share, okay? So these are the growth rate of them. And after some manipulation, again, by ignoring the time change, I mean, that was inspired by, in fact, it should also be, you know, the same like this, and this should be, and there's a mistake here. This will be 2, and this will be Fk multiplied by K over Y. So investment share and the share of natural resource rents is directly determining the per capita income growth in this economy. That's why we are going to use this and also this equation as the base of empirical strategy for empirical estimation. Okay, so let me continue with the empirical strategy here. As I said, we are going to use these equations, but we are going to do it in a panel data setting. So in a dynamic panel data setting, because this is, when you put this here, it will be the economic growth rate, the final equation where we have already just derived. And there will be some explanatory variables. This is the unobserved heterogeneity, and this is the of course, time invariant unobserved heterogeneity, and this is the time variant heterogeneity, and this is the idiosyncratic error term, which confirms or satisfies the classical assumptions. We have then it defines the countries, the number of countries with resources here. In fact, we have a few countries, 2 or 3 countries without any resources. I mean, their resource rents are 0. I also included them in the estimation. Dropping them did not change anything significantly. That's why we kept them in the data. And the time starts from 1970 up to 2070. We can express our model in a more detailed way in this way. I mean, this is the lag dependent variable here. The explanatory variables, the investment share, as we have just explained here. This is the investment share. Okay. And there will be, the share of resource rents here. We put them as the base. And also, we also added the interaction between these 2 variables as the multiplication, the investment share and the share of natural resource rents, as we have just explained. There's an interaction between them. The share of resource rents affect the investment share in this economy. Also, in order to control for the exchange rate movements, the Dutch disease, I mean, we also added the exchange rate and its interaction with the share of resource rents into this model. So this will be the first regression we're going to run. Obviously, as this is a dynamic panel data, pooled OLS or a fixed effect estimation will not be very suitable. It will not be convenient because of the nickel bias. This will be correlated with the error term here, so it will raise some endogeneity issues. In order to control for that, we are taking the estimation approach of system GMM proposed by Arellano-Bond, Arellano-Bower, and Blundell-Bond, and of course Windmeyer correction in 2000 paper. This estimation method, as probably you are very familiar with this, using instrumental variable estimation methodology, and using taking the difference in this approach, you're taking the putting the model into a different term in order to get rid of these unobserved heterogeneities. And also you are using the lag level of instrument, endogenous variables. You are supposed to have here, this is endogenous variable. Investment can also be endogenous. We haven't discussed it, but it can also be, it is in fact endogenous because it is affected by the income level. Also, the share of resource trends can be endogenous, and we are using the lag level of this. In system GMM, in addition to the different equation, we are using the level equations and differenced by, instrumented by the difference lag level of instruments. So we have such an empirical estimation. In order to have, some anchor to evaluate, to understand, or let me say post-regression statistics, Arellano and Bond proposed two tests for system GMM estimator to assure the exogeneity of variables without any problem, to obtain the reliable results. The first one is Hansen test of over identifying restrictions. If this is not the robust version, if you are not estimating the robust standard error, it turns out to be Sargan test, but they are equal, as you probably know. And the second one, the autocorrelation test. The order should be dependent on, of course, on the used level of used lag level of instruments. If you are using second lag, the second order of autocorrelation should not be, and there should not be any autocorrelation. If you are using, for example, the fourth lag level, then you're looking at checking that autocorrelation. And our data set is consisting of Penn-World table data set. And also the natural resources rents are taken from World Bank data. The data is in between 1970 and 2017. And we, as in all growth studies, generally, in order to get rid of the conjunctural changes, we are putting them into 5-year means. And the system GMM estimation requires the cross-section units should be greater than the time dimension. That's why we put them into 5-year means. We have 170 countries, and as I said, only 2 or 3 countries are without any natural resource rents, even though very low, which I'm going to show some picture in a moment. Even though they are very low, very close to zero, there are some resource rents of many countries out of these 170 countries. As you know, there are almost 200 or slightly over than 200 countries in the world. And the 174 and 3 observations is missing for the share of resource rents and investments. So we dropped them from the data set. And that some of the countries were missing for income per worker. So it was easy to interpolate to have income per worker. That's why we interpolated 57 missing observations in our study. Let me present you some descriptive statistics. We have 1,508 observation GDP per worker in log term. Okay, so the mean is around 10. Standard deviation is very low, in fact. And this is the minimum and maximum values. Investment share is this, the mean is around 60%. The investment share of all countries in the world is around 60%. And the standard deviation is very low, and it climbs up to 85% almost. Share of resource rents is again very low, is around 7% here in all over the world. As I said, there are very limited number of zero natural resources rents, but it climbs up to again 85%. We have the exchange rate here, so it's defined as purchasing power parity exchange rate, defined in the Penn-World table. The correlations are like this. So investment share is correlated with GDP per worker as 13%. The share of resource rent turns out to be negative. So as you have more resources, you are supposed to, I mean, it looks at the first glance that you are supposed to have lower GDP per worker. Also, exchange rate is negatively correlated with GDP per worker. All right, let me show you this picture, the income per worker versus the share of resource rents. Resource rents is measured on the horizontal axis here. It climbs up to 50%, as you can see. I just dropped one country because the picture then becomes very unreadable. So this is the income per worker. As you can see, many countries have very low resource rents, close to zero and less than 10%, as you can see, many countries, even Norway. And other countries like some sub-Saharan African countries here, Russia, Chile has, you know, resources for copper, mining copper, and Armenia, Brunei, Qatar, Saudi Arabia, Oman, Kuwait, and these are the oil-rich countries, and their resource rents are very high, as you can see. So we cannot simply drive out any, you know, significant relation if it is positive or negative. We cannot put it in that way. I mean, we cannot reject or accept the resource curse hypothesis by just looking at this picture. You can either obtain a negative or positive result after running a regression of the share of resource rents on income per worker. So it's not giving us a clear-cut picture. We can also look at the investment share versus the share of resource rents, the previous one, GDP per worker. We said our hypothesis, the main hypothesis here is investment is affected, negatively affected from the resource rents. Perhaps we can obtain a negative relationship. We can obtain a negative relationship if we ignore these countries located in the southwest region of this picture. And again, the picture does not give us a very straightforward results. We need a further empirical estimation. And the exchange rate and the share of resource rents here are not, again, giving us any linear and direct relationship between the exchange rate and share of resource rents. I mean, we cannot say that by looking at this picture, if the Dutch disease, you know, is a main issue, main problem in these kind of countries or not. So we need to look at further or more detailed analysis. Okay, so let's continue with the results. I think we have 10 minutes or something. And this is the results of the first estimation. For the benchmarking purposes, I also put them pooled OLS and fixed effects estimation with and without interaction of the base model. I mean, equation 17, as far as I remember, and 22, right? And without, due to time restriction, I'm not going to spend time on pooled OLS and fixed effects, but we can, we can look at the system GMM results in these two columns with and without interaction. The results are not very different in terms of lag-dependent variable. However, the share of investment coefficient is very different. You know, it's more than double in an interaction model, and turns out to be significant at the 1%. Here, we don't have any significant effect of investment share on income per worker, which is contrary to our theoretical expectations. The share of resource rents is negative here and significant. However, in the interaction model, it turns out to be insignificant. Let me tell you that in an interaction model, the coefficients of interacting variables cannot be directly interpreted. That's why I should not, in fact, compare this. Let me just talk about this, and then I'm going to present the marginal effects. And the exchange rate has no significant effect on income per worker. Here we have the interacting, I mean the multiplication of, for example, investment share here and the resource rents, and also exchange rate and the resource rents, the multiplication of them, we also obtain the coefficients. However, as we have also share of resource here and coefficient, and also here, in order to understand the effect, we need to have some further calculation to understand the marginal effects of this variable on the dependent variable. Why? Because in a simple linear regression model, if this is an interaction model, we have X explanatory variable, Z variable, and the multiplication of them. If I'm interested in the effect of Z on Y here, I'm not, it will be mistaken to take only the Vita 2 here. It will be, I'm sorry, this should be Vita 2, because the effect of, or okay, let me say, if I'm interested in the effect of X here, I can not simply say that this is the effect, Vita 1, but the effect of X on Y should be taken as a derivative of this function, which is Vita 1 plus Vita 3 and Z. And if Z is a continuous variable, which is generally the case, if it's not a categorical variable, the significance and the magnitude of the derivative should be evaluated at the slices of Z. We can take different slices of Z variable, like 10%, 20%, up to 100%, and calculate the magnitude of this derivation. And we need to calculate the standard errors and this the hypothesis testing of T again to understand if the effect is significant or not. So I did this task, and these are the results of this calculation. So, for example, this column presents the share of resource rents in our interaction model at different slices, starting from 0, 10, 20, 30, up to 100 here. The effect of investment share on income per worker can be listed as in this first column. I'm sorry. When there is no resource rents, the effect of investment share is around 12%, 0.12, which is significant at 1% level. When the resource rents climbs up to 10%, this effect turns out to be slightly reduced, like 11.6%. Okay, again significant at 1% level. As you can see, as the share of resource rents increases, the investment share is becoming less and less effective on GDP per worker. As you see, the magnitude of this coefficient or this derivative is declining below 10%, 8%, 7%, and reduces finally at 5%. It starts from 12% here and reduces to 5%. So there is a clear relationship of interaction between the share of resource and investment share in terms of becoming effective on GDP per worker here, income per worker. If you have less natural resources, your investments are more effective on your income. Okay, and this might be, a conclusion perhaps, but I'm going to explain it in a moment, because there can be an effect that their GDP are higher in terms of when you consider windfall gains out of natural resources, and of course investments in all economic activity must be less effective on GDP per worker. Exchange rate is not significant at all levels of natural resources, so we cannot derive out any significant results out of Dutch disease. And when we look at the different levels of investment share, because this is the multiplication of two variables, we can also look at the share of resource rents solely on GDP per worker. And as you can observe, there is no significant results out of this calculation. It is generally customary to represent these kind of marginal effects of marginal effect calculation visually. This is what I did here. In figure 4, we can observe the marginal effects of investment share on GDP per worker. Here, the effects on fitted values we observe. and this is the share of resource rents. As you can see, there is a very clear negative relationship, and these are the confidence intervals. These are the confidence intervals, okay, at 5%, yes, in 95% confidence interval. And as you see that both confidence interval lies above the 0 point, I mean, doesn't take negative or positive values. That's why we can say that this is significant. Visually, we can conclude this result, that investment share are effective. There is positive effect of investment share on GDP per worker. However, this effect declines as the share of resource rents increases. And the marginal effects of the share of resource rents is depicted here. As you can observe, the confidence interval both lie both on negative and positive regions. Even though this is positive, we say that share of resource rents are not significant in this estimation. Okay, I said that I'm going to estimate two regression, but by the way, do I have any time? Am I left?
Actually, we are close to the end, but you can go on.
Okay, very briefly then. Sort of robustness analysis. I'm going to also present the estimation results of investment function. I mean, this is the main hypothesis that the growth rate of investments, this is the equation 17 or 22, I'm sorry, is a negative function of resource rents. This is our main hypothesis. Again, this is a dynamic panel data. We have consumer share. We said that the resource rents are effective on investment share out of consumption. That's why we also added it here. And it is the effect, the channel effect, the multiplication. I'm skipping the descriptive statistics and the correlations here. You can just observe. Again, we have 1,508 observation, and these are the correlations. Let me directly go into the system GMM estimation results. Again, as this is the system GMM with interaction, we cannot interpret the coefficients directly, but let me explain the post-regression statistics, the exogeneity of regressors. The Hansen test, where is it? It is 800, so it satisfies the exogeneity. We used fifth leg of some instrumental variables, so there is no autocorrelation at that level. That's why we can also use that. The number of instruments is also important here. I forgot to mention in the previous results that we have 170 countries compared to cross-section units. The number of instruments can be considered as minimum, very low. So these three statistics are very important to have an idea about if this is a good estimation or not. Okay, so the marginal effects are like this. The consumption at the initial level of resource rents, the consumption has not significant effects, but later, after 40%, as you can see, starting from 10%, 5%, and 1%, there will be negative effect of consumption on GDP per worker. I mean, you are feeling yourself in a safe environment. That's why you you don't have to put more resources into your capital stock. I mean, into your saving and investment. This is the idea we have used in this paper. But we obtained significant and negative results, coefficients or derivation effects of resource rents at varying consumption levels, which is starting from 33%, minus 33%, which is significant at 5% here, climbing up to 81% when they evaluated at the consumption. So we can say that resource rents are reducing GDP, resource rents are negatively affecting investment levels. This is our results. And this is the picture, the marginal effect of consumption. As you can see, the confidence interval both lies on negative and positive regions, but the marginal effect of resource rent confidence intervals are in the negative regions, and we have a negative function here, which says that resource rents are negatively affecting investment. Briefly, the conclusion, I'm closing. The resource curse hypothesis in this paper, confirmed, accepted, specifically in particular by the investment channel in these countries. So our hypothesis as the investments are suboptimal in these economies are also accepted. The investment is a decreasing function of the resource rents. And the resource rents in these resource-rich countries flow more to consumption to increase the current welfare, and they don't care about future consumption. They don't, because they are not taking into the uncertainty of future. We don't have any evidence for the Dutch disease in this study. There could be in another studies. However, the reduced investment, what does it mean? The reduced investment does not only limit the current growth rate, but also it threats, it endangers the sustainability of the future economic growth because of the, the sustainability issue. We said that the resources are, depleted, and the greater share of investment is desirable to overcome the resource curse hypothesis in these economies. I'm sorry that I exceeded my time, but thank you for listening to me. That's very kind of you. Thank you.
Okay, thank you very much, Aykut. We had the opportunity to have an idea about one of the most important problems of resource-rich economies in the world, and with your hypothesis that investment in resource-rich countries are suboptimal, and we saw that it is suboptimal, and your presentation was really lots of information to us. Now I have actually a question, but let me firstly ask to the audience, is there any comments or questions from the audience?
Srihoja, can I have a question?
Yes, please.
Yes, just raising a question about, we have now fossil-rich countries, and they have a high GDP, or they have a high GDP per capita. But in the future, if we assume that, or the trend is, let's say, from the fossil resources to the renewable energy, if we say that this trend is increasing, how does affect the GDP or GDP per capita of countries in the future?
Yeah, in this case,
what is your expectation?
We can assume two things here. That's when these resources are, gone. Let's assume that there's no oil in the world at the moment. That they will be very poor, obviously, because their investment level are very low. The diversification of economic activity is very low. But if the renewable energy cases like solar energy and wind energy can be replaced, yes, it is okay. But there will be, the market structure will be different in this case. In terms of energy market in the world, many other countries, for example, Germany is also very solar-rich country because they have a huge solar fields producing solar energy, even though they don't have the solar energy in a greater part of the year, greater months. For example, they perhaps see only 4 months or 5 months in a year, as opposed to 12 months in sub-Saharan Africa. In this case, the market structure will be different, and the demand for their energy will not be as high as this much. So the income generation will be much lower in this case. I can say this.
Okay, thank you. Any other questions from the audience? Okay, as far as I can see, no. Erdal Hocam, do you want to add something? No. Okay.
No, thank you.
Okay. Okay.
Was it satisfactory for you? Let me ask. Was it satisfactory? Let's turn it into discussion.
Yeah. Mm-hmm.
No. I mean, my answer, was it satisfactory?
Yeah, it's okay. Thank you.
Okay then.
Okay. I will just ask something about dividing the countries into 2 groups. With countries with low share of resource strength and with the ones with high share of resource strength. Can that for those figures, for example, can that affect the results? Because and can it be useful to make a separate analysis like that?
Yes, that can also be very interesting. For example, I'm sorry, we can split the countries with 10% and above 10%. In this case, we can diversify this analysis, and in this case, probably, I'm not sure about the investment function, but probably about the consumption for the low share of, for the second regression analysis, I mean, probably we're going to get the same results. The share of resource strengths will be negative on investment level, will be negative investment level. I'm sorry, true consumption. I'm talking about the share of resource strengths are not very much affecting consumption in those countries. That's why the effect on investment level is very low. However, for those countries with high resource strengths above 10%, perhaps, it will be very effective in terms of consumption and the effect of consumption over, or I'm sorry, the share of resources over consumption on investment level. Probably the result will be the same, but of course, I need to do this exercise for the GDP per worker regression. I need to run again a separate regression in this case, but that's a good point. I can also try it.
Okay. Okay. Thank you. Okay. Thank you very much, Aykut, for this very informative presentation.
Thank you very much for inviting me.
And let me say that we will have our next lunch and seminar on 25th of May with Hasibe Aysan from Austin University. And the other one will be on 8th of June, again from Austin University, Bahar Erdal. So see you again on 25th of May, and and I am taking this as an opportunity to wish you good Eid of Ramadan to all of you, and see you next time.
Thank you. Cem Bey merhaba. Nasılsınız? Sesiniz, mikrofon kapalı.
Şimdi açtım hocam. Sağ olun. Siz nasılsınız? İyi misiniz?